Okay, well, I've been gone for a couple weeks. Went over over to Wyoming. Spent some time in Colorado, then went up to Wyoming to see the solar eclipse, which was great. And when I got home, this was in the mail. So I'll show you the design for this in a bit. But this is since I was leaving for a 2-week vacation, I thought, oh, I could get a board out, pay for slow shipping, and maybe when I get back, the board will be here. So that's what I did. So again, $2 of boards and $10 of shipping, and it was waiting for me when I got home. So pretty cool. So let's open this up and take a look, and then I'll show you, like I said, I showed the design files for this. I whipped this out really fast, so I'm expecting I probably made some errors, but I figured for $2 and some time, why not get some going. So this is an interesting board. Let's see, let's count how many we got first. 2, 4, 6, 8, 11. Yay! Got one extra. Okay, so let me show you just one board. There you go. Let me zoom in a bit on it. All right. So this is a very strangely routed board, just to save me some cutting on the garage. So this is a board here, and 2 indicators, and a board here and a board here. So 1, 2, 3 boards plus some indicators. So let's start with the little one over here. This is the RAM board, and what I did was add the indicators so you can see the memory address with an indicator attached. So that's an improvement. That was suggested by a viewer. I liked it, so I laid that out. This is the program counter with the bits flipped around the right way. So we should be able to increment, and it increments instead of decrements. So that's handy. And then the last board, which I kind of threw in at the last minute because I just had some room, and I didn't know what else to do. I was leaving for vacation and was out of ideas. And I thought, oh, wait a minute. I'm going to finally get around to writing a program for this thing. Where do I put it? Certainly you could program it in the RAM, and then every time you turn it off, it goes away. So I created this board, which is a ROM-RAM board. It has 256 bytes of locations. That's the memory. It's an 8-bit memory space. And so I memory mapped it such that the lower 128 is ROM and the upper 128 is RAM. So we'll be able to create a program here in ROM and then execute it out of RAM. So that would be great. So we'll see if that works. Like I said, I did this really fast, so hopefully I didn't make too many errors. The back looks pretty clean. I laid it up pretty good. That was good. Yeah, so I'll have to saw these up and try them out. But let me show you the designs on the CAD. Okay, here's the schematic for the board. Start over here. This is just our standard RAM. We have a latch, and we have the RAM. And this time I have all the bits going the right way, so I believe that's okay. Maybe they're backwards, but it doesn't matter with the RAM chip anyway. The thing that I inserted here was the this header here, which would allow you to put an LED indicator onto the address lines. So that was added. Otherwise, this is the same as last time. The program counter is the same as last time, except for the bits are right way around this time. So 2 counters and a buffer, and let's see here. Also, there is an indicator, I believe. Yeah, so you can look at the program counter with an indicator. And then the one that I kind of crashed in at the very end was the ROM-RAM. This is the ROM, this is the RAM. There's a latch that sets the address bus, which again will have an indicator on there. And then we use the 7th bit. Um, so instead of routing the 7th bit to the chips, you can see that the A7 is always enabled, it's grounded. And the 7th bit is used for the chip select. So let's do an investigation here. So here we have the chip select for the RAM going to this inverter. And the input to that inverter is the address line 7. And then the chip select for the ROM is the address bus 7 directly. So this one has address 7 inverted, and this one has address 7. So when it is low, we chip select this one. This is a not chip select. So when address 7 is low, we are looking at ROM. And then when address 7 goes high, it deselects this chip, and then it gets inverted. So this line goes low, and we chip select the RAM. So ROM is the bottom 128, and RAM is the top 128. And we have a bunch of leftover inverters. Okay, let's take a look at the layout. All right, and let's turn on the. So again, RAM is the same as before, but I've added a LED indicators. Program counter is before, there's indicators, and it's the right way around, so it looks a bit different. It's upside down to get the layout correct. But again, it's D0 through D7, right to left, so it's the right way around. Program counter. A couple indicators with different polarity, depending on what you want to plug them into. And then the ROM RAM. So we have the latch from the bus. It goes to a memory address, which we can put an indicator on. Here's our little inverter, which we just needed one gate from. I believe you can buy just little single inverters, but 04s I had. So, and then again, this is the RAM chip, and this is the ROM chip, and it's a through-hole. It's the same chip that I use for the microcode machine, so I didn't have to buy any new chips, and I know how to program these. So that's what I'll do. So we can run a program here. In fact, we could probably write a monitor program eventually that will live in here and will allow us to execute memory instructions or be able to examine memory and step through it, things like that. So that might be interesting eventually. And then you can see how I've laid out the board to minimize the amount of cuts that I have to do. I put this big notch in here, and then I'll just have to make 1, 2, 3, 4 cuts, and everything falls apart. Anyway, that's what it was. Like I said, it was waiting in the mail, and we'll try it out and see how many errors I made on it. Maybe I got lucky.